This is 19 diseases of the immune system. So we're going to begin with different kinds of allergy. Allergies can actually be quite life-threatening. Bee stings or ingested proteins from peanuts, for example, right? Those can cause something called anaphylactic shock, and it can definitely cause so much swelling in your airways that you can't breathe anymore. So what generally the allergens that cause such really systemic, intense allergic reactions are injected, such as bee stings, right? So injected into your body, or ingested, ingest as in food, right? So we think about the people who have the most severe responses to an allergen. It's, bee stings, injections, ingestion with peanut butter and peanut protein. For those people, they might want to carry epinephrine. So basically what happens is when we have an allergic reaction, our tissues kind of get swollen, which leads to a drop in blood pressure. So all that liquid that came from the bloodstream is now in your tissues, and all that blood pressure is lost. And that sudden loss in blood pressure, that's called shock, severe drop in pressure. And epinephrine, right, we kind of know this as adrenaline, it counteracts that. It kind of tightens up our blood vessels, and it tries to increase our blood pressure. All right, so beginning with allergy, we are going to have 4 different kinds, type 1 through type 4, and they are written as Roman numerals. And we'll start with number 1 and just work our way through. So we can see that type 1, we have antibody, 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 and then T cells. So something to sort of keep in mind is that once we go through all this, type 1, type 2, type 3, they're all mediated by B cells, right? Because B cells make antibodies. Antibody, antibody, antibody. And then the last one here, type 4, is a T cell that is responsible for that. All right, so type 1 is called allergy, like an allergic response, right? When you have hay fever, when you're allergic to a dog or a cat, this is what happens in your body. So the first exposure, we're going to start with number 1. So the first exposure to allergen. So allergen is used in place of antigen here because it's going to produce an allergic response rather than a specific immune response. So allergen comes in our body. It does what, your body does what it does with allergens or any antigen. It's processed. MHC class 2. T helper cell gets stimulated. B cells are stimulated as well. So B cells have seen the same allergen, B cells and antigen-presenting cells. So we can see that this is a T cell mediated immune response for B cells. And so it's a rephrase, T dependent B cell activation. Your B cells will then proliferate into their memory cells and also into their plasma cells. The weird thing about these plasma cells, though, is that they do not, remember what the antibodies are supposed to secrete? They're supposed to secrete IgM first, right? They're supposed to make IgM, and then they make IgG during the first immune response. But something is a little off here because in allergy, IgE is made. So what IgE does is it has that, remember we talked about how we have that Fc fragment down here. Mast cells and basophils both have IgE docking sites, right? So the IgE binds to mast cells by the Fc region, and that is what we called sensitizing the mast cell. Okay, so I'm going to draw a little bit of a line here, just like box off number 5, because number 5 is the second exposure. So everything happens here with your first encounter with any allergen. So if it's a pollen, you're kind of allergic to. You actually don't have a immune response because when you create this IgE, the IgE, it goes and finds a mast cell and just kind of sits on the mast cell. So during the first response, you have become sensitized, meaning that the antibodies that recognize this antigen, or the allergen, as we say, have been, multiplied, and all of, not all, but like many, many mast cells in your body. Remember, mast cells are underneath your skin and mucous membrane. They are going to be ready to encounter that the second time you see that allergen. So number 5 is the second time. When you have the second exposure, the allergen comes in. There's a important little feature here where you have to form a cross bridge. So you notice how this allergen is spanning 2 different antibodies. So they're linking the 2 antibodies. That is the trigger that causes your allergic mediators to get basically released. And this is called degranulation. Okay, so when the inflammatory mediators, right? So we can think about leukotrienes, histamines, bradykinins. Those things are going to be secreted out, right? They all cause inflammation. They all cause vasodilation, loss of fluid to the surrounding tissues. That's what's going to happen with this response. So once you have that second cross-link, right, or the first time you get the cross-link in your second exposure to the allergen, we're going to get the symptoms because now you have your inflammatory molecules. All right, let me just talk really quick about the difference between atopy and anaphylaxis. Atopy is allergy, it's local. Okay. Atopy is your hay fever, it's sneezing, it's itchy eyes, it's an itchy throat, maybe. Anaphylaxis is going to be systemic. Okay. So remember I talked about anaphylactic shock. What happens in anaphylaxis is that it's a body-wide reaction, but the mechanism is exactly the same. So for some reason, right, someone can get like an allergen into their body, the IgE is made, and then the reaction, the second time you see that allergen, the reaction stays in the head and neck, right? Itchy eyes, itchy throat, runny nose, all that stuff. But somehow, some people have an anaphylactic reaction, which is basically a many-fold time more degranulation. So we have really excessive degranulation, just over degranulation, which goes into the bloodstream, leads to body-wide inflammation. Think about hives all over your body, and then severe swelling. So your head and neck, the soft tissues there can completely close up and cause you to stop breathing. So the difference between these two, right? And atopy is local, anaphylaxis is systemic, and anaphylaxis, right, we talked about here, can actually drop your blood pressure so much that you could lose blood to important organs. So for those of you who have a history of body-wide hives due to an allergen, it might be smart to carry an EpiPen, which is what this is, EpiPen, that will put adrenaline or epinephrine into your body to counteract any sort of massive blood pressure drop you have. And just to say one more time, that blood pressure, when it drops, it's called shock. So if it's shock in response to an allergen, it's called anaphylactic shock. Okay, so we have atopy and anaphylaxis. The second type 2 is going to be IgG and IgM mediated. So we talked about blood types very briefly in terms of IgM being, here you have a picture of IgM, right? So it is a pentamer. And what you see here is that we have these blood types. So we have the A, B, AB, and O blood type. I'm sure you guys are familiar with this, but the A blood type has just the A glycoprotein surface marker. The B blood type has a different glycoprotein surface marker. AB has both of them, and then O has none. These are the antigens that are going to be foreign to a person who doesn't have that blood type. It turns out that your body makes isohemagglutinin, basically the antibodies that are different blood types. So if you're type A, in your blood right now, you already have anti-B antibodies in it because the B antigen is going to be foreign to you, right? You're not familiar with B. It is a foreign entity to your body. And so you have anti-B antibodies already floating around there to be ready to attach to any sort of red blood cell with a B on it. If you're type B, it's the same thing. You have anti-A antibodies. However, look at AB. Both A and B are self, right? Remember, this is all self versus non-self. So if you're okay with A or B, you're not going to have antibodies against them because that would be antibodies against yourself. So you would have no antibodies circling in your bloodstream. However, if you're type O, then both A and B are going to be foreign to your body. And so you're going to have both of those antibodies in your bloodstream, anti-A and anti-B. Okay. So when we think about what's in the bloodstream, right, we can think about donation. And let's talk about this chart. So we have blood type, antibodies in our serum. Who can we donate to and who can we receive from? Okay. So if I'm blood type A, and we're ignoring the plus and minuses, right? We're not including the Rh factor here. This is just a thought experiment with just A and A, B, and O. A, B, and O. What antibodies do I have again? I have anti-B because B is going to be foreign to me. However, if I'm B, I'm going to have anti-A antibodies. If I am AB, I should be cool with both A and B, so I'm not going to have any antibodies in my serum. And if I'm type O, both A and B are foreign, so I'm going to be ready to fight them, anti-A and anti-B. Okay, so that's antibodies. Now, let's think about who we can donate to. When you donate blood or receive blood, it's a little bit different. They're not the same. So if you're type A, who can you donate to? And I don't want you to think about this. Don't think about the antibodies. Just think about the antigens when you answer these two questions. So if you're type A, you basically can donate to anybody with an A, okay, because A is not going to be foreign to them. So who has an A? Type A has an A, and type AB has an A, right? You can donate to both of those guys. What about if you're type B? Who can you donate to? Anybody with a B. B, AB. If you're type AB, who can you donate to? Anybody who has A and B, which is only one blood type, and that's your own, AB. If you're type O, you do not have any antigens, right? You don't have any A's or B's. So you're basically like a bald, you don't have any, I'm going to put bald here, but you don't have any antigens. You don't have nothing to reject. So you can donate to anybody because no A, B, AB, and O, right? They're not going to reject anything on an O blood because O blood doesn't have any antigens on it. All right, now we can think about receiving blood. This is different. So if you're type A, who can you get blood from, right? Definitely A's are okay. And O is okay, right? Because it doesn't have anything for you to reject. But is AB okay for you to get? No, because B is present. You don't know B. It's a foreign entity to you, right? Let's look at B. Who can you receive from? Definitely your own blood type. And then the baldy. Okay. If you're type AB, lucky for you, you can receive from type A because that's not foreign, that's you. You can receive from type B because B is also something you have. AB is your own blood type. And you can also receive from O, right? So if you're type AB, you have all the antigens, nothing's going to be foreign to you. If you're type O, unfortunately, Everything's foreign to you. Who can you receive blood from? Only O. So this is how we want to think about who can receive from and donate to. All right, when we add the pluses and minuses, it gets more complicated, but we're not going to do that. We'll just stick to this. And then once we hit the pluses and minuses, the RH factor, we're going to look at hemolytic disease of the newborn. Okay. Before we get to hemolytic disease of the newborn, this is going to be basically our picture of our blood compatibility. Type 2 hypersensitivity, IgM. So we can see that our donor is type A, our recipient is type B. Right? Our type B recipient has an anti-A antibody already there, right? So we know that the antibody is going to make sure to link and attach to all those antigens on the surface of B cells. On the surface of A cells. It's going to agglutinate, right? Form really big units, these big clumps of our wrong blood type. And then it'll cause complement to come in and lyse those red blood cells. So remember how complement can form the MAC complex, MAC attack? It can form like a pore and basically just punch a hole right in through the red blood cell membrane. So it will destroy the red blood cells coming in, okay? And it does that through the MAC. It does that through complement, all right? It doesn't do it through B cells or anything else like that, or T cells. It does through with complement. All right, let's talk about hemolytic disease of the newborn. So this is going to be a massive destruction of a fetus's red blood cells. Well, if the disease progresses, right? Massive destruction of the fetus's red blood cells causing anemia, right? That's the loss of red blood cells, loss of oxygen carrying capacity in the body. It can cause jaundice because our red blood cells contain heme in the hemoglobin molecule. And that heme gets turned into bilirubin, which is a yellowish color. And that yellow color, if it's not processed appropriately, then it can go into the bloodstream and it can color your skin and eyes yellow, which is jaundice. Enlarged spleen and liver. Why an enlarged spleen and liver? Because those are the two organs that are responsible for clearing dying and dead red blood cells. So you're basically overwhelming them with dying and destroyed red blood cells in this case. So that's why the fetus would suffer from anemia, jaundice, and enlarged spleen and liver. Okay, so how this would progress. How does hemolytic disease of the newborn, under what circumstances would it arise? You must have an Rh negative mom. Okay, so Rh, the rhesus factor or the D antigen, is not present on her blood. So the Rh factor is a foreign entity, right? It's going to be something that her immune system wants to fight. If the dad happens to be Rh positive, they would have an or they could have, right, an Rh positive baby. So now the baby's blood type has the positive Rh, or it is positive for Rh. And the mom does not. So normally, under sort of like normal conditions, healthy conditions, the baby's blood cells don't enter into the mother's body. The placenta takes care of that. However, there's always a chance, maybe during birth, maybe during the detachment of the placenta during afterbirth, whatever circumstance might arise, there's a chance that some of the baby's Rh positive cells could leak into the mom system. So this is sensitizing the mom. So the mom's immune system here has learned that that Rh factor has been around and is going to create memory cells and it's going to create IgG antibodies. So these are going to be anti-Rh, right? Because these antibodies are going to recognize Rh and their IgG, meaning that they can cross the placenta. So here's the thing. The IgGs don't usually form in the first pregnancy. This is going to be our first pregnancy because the exposure to blood is going to be very late, if any, right? In the trimester, maybe it's during birth. And the mother's immune system needs time to get sensitized. So while she's not pregnant, her immune system's making these anti-Rh antibodies. And if if she's not treated, and there's a second pregnancy, and the second pregnancy has an Rh positive fetus again, guess what? IgGs can cross the placenta. So it can actually fight the baby's, basically destroy the baby's red blood cells while the baby's inside the uterus. Okay, this is your textbook illustration of the hemolytic disease of the newborn, right? So here again, we have an Rh positive baby, Rh minus mother, and we have some leakage of blood cells into the mother's body. So one thing to remember is Rh is different than the A and B. With the A and B antigen on red blood cells, you already have the antibodies ready to go, like the anti-B and the anti-A antibody. For Rh, you don't. You have to be exposed to it first, and then your body makes the antibodies. So when your blood comes in, right, it takes the mom's body needs to get sensitized to it, and then will make the antibodies against Rh only upon when it enters into her bloodstream. So the anti-Rh antibodies remain in the mother's circulation. And then what can happen is the maternal anti-Rh antibodies attack and destroy the fetal Rh plus red blood cells. The fetus becomes hemolytic, which is hemo means blood, lytic means lysing. So the blood cells are lysing. Okay, so notice that the first pregnancy, the mom gets sensitized, right? So we have the first pregnancy here, numbers 1 and 2. And then we have the second pregnancy where we actually have crossing over and destruction of the fetal red blood cells. All right. In letter B, this is how we treat hemolytic disease of the newborn. Okay. We treat it with something called RhoGAM, or this, Rho-D. And basically what it is anti-serum. So it's anti-Rh antibodies. Okay, so here's the idea. We know, right, the mother gets pregnant. We know the mother's blood type. We don't even care about the baby's blood type. We just care about the mom. Mom is negative. So we know that if the baby's positive, this disease can occur. Why don't we go ahead and just put an anti-Rh antibody? So this is a serum, right? This is passive immunity where we're giving the mom antibodies that recognize the Rh, right? Anti-Rh. So what this does is if at any point during pregnancy, some of those baby red blood cells come out and it has the Rh on the top, the anti-Rh antibody that is from the medicine is going to cover up those Rhs on the baby's blood, basically like masking them. Remember, like neutralization? We talked about how antibodies can just cover and coat cells, epitopes, and to prevent binding. So what this is doing is the anti-Rh antibody comes in, binds to all the Rhs on the baby's red blood cells, so the mom's immune system does not catch wind of it. The mom's immune system never gets sensitized because it's immediately covered up by RhoGAM, right? So the Rh factor is never out for the mom's own immune system to make an immune response towards, right? So the RhoGAM, again, is to cover up any Rh factor that might come into her body before she gets sensitized. So it's very important that this is done before the mom is sensitized or with the first pregnancy. If the mom has already been sensitized, if she had a kid, the second kid is now Rh positive and she's Rh negative, it won't work, right? Because she already has her own antibodies and they're going to cross the placenta. All right, this is just another look at RhoGAM, anti-Rh anti-serum, right? And the only circumstance where you would need this is if you have an Rh mother, or sorry, Rh negative mother, because the baby could be Rh positive, right? And so if the mom's immune system ever gets sensitized to the Rh, her IgGs can cross the placenta. So the RhoGAM comes in. It's an anti-Rh antibody. Any red blood cells that might enter into her system, that antibody is there to cover up any of those Rh factors so that the mother's immune system never sees it and is never sensitized. All right, so that's good enough for part 1.